Hey guys, welcome to my channel. So tonight's video is about this brand new circuit I just made. So this is a reed switch circuit. So these little bitty reed switches that so much of us used and burned out in the past. This little circuit uses this as a timing, but then it's amplified by a transistor and a MOSFET, and it actually can run on both, which is really cool. So this could do up to 5 amps. This one is about 1 amp. And yeah, it's a really cool little simple circuit. I have it available on my website in case any of you are interested. And then what we did is printed out a new rotor. So this rotor is all monopole, so all north facing. There's 2 stacked magnets on it. This is just a 3D printed wheel. So if you guys need something like this also, you could just leave me a comment or get a hold of me on the store. So the coil is the same coil used on the Bedini motor, so it has an extra wire on it. It has a welding rod core, and yeah, it's just a really simple setup. Got the reed switch just kind of hooked here in the plastic, and as the typical circuits go, I have the positive and negative, and then I have a real nice big fat diode that pulls the power off the coil and then routes it into here. This is just like a Bedini output circuit. So the negative is tied to the positive of the primary battery. So you always want to go into a second battery on these circuits. So yeah, so the output comes out in the white and yellow and then goes through the capacitor dump. This one's triggered at 16 volts. And we'll be able to see the battery charge and see what's going on. So if you guys are interested in this circuit, none of the wires come with it, but it does come with MOSFET and a transistor with the heat sinks and everything. So it's really cool to experiment with. So this motor, since it's in repulsion, they normally start up if it's timed right by themselves. So we'll just start this baby right up. So this is with the transistor. The aluminum color transistors, or heat sink is on the transistor. So here's our waveform. And the little reed switch is doing its thing. Just a really simple setup. Definitely for people that are learning about pulse motors and stuff, it's really nice because you can just move this reed switch wherever you want to kind of figure out the timing, things like that. And then, so right now we're using just a hair over half an amp, and this is our return coming out of the cap dump. So it's quite a bit of power coming out. We're about 3.5 amps about every 3 seconds. And so what we're going to do now is I'm going to slow this down, turn this off, and we're going to put a little bit of load on this. So with the transistor, it pretty much maxes out at 1 amp, because I have a certain resistor in here to protect the reed switch. So the reed switch lasts a long time because it's not connected to the coil, so there's no sparking or anything in it. So it works really nice like that. So let's fire this back up. This is like a 1 foot diameter RC plane fan, basically, just to give it something to load against. And it's not really using a whole lot more. So the transistor is kind of neat because it does limit it. So no matter how much you slow it down, it's not really going to use any more than an amp. So in some circumstances, that's really convenient. It makes the cap dump run really nice. But as far as this goes, since this is not a Bedini circuit, this is just a timed circuit. So the faster it goes, the more output you get on this. So under load it runs nice, but the output's real slow. So what we're going to do now, let's take this off, and we're going to put the MOSFET on here now. So we can take off the scope leg. So these just pop off real easy, and I just pre-bent it to make sure it goes in the right direction. Same with the MOSFET. Okay, so let's fire this thing up. So the MOSFET, much more power. You know, this will do with this coil up to 5 amps. And here's the waveform. It's a very, very square waveform. And let's zoom back on. So now it's kind of surging with the cap dump a little bit, but we're charging really fast now. The MOSFET definitely does a good job at making really strong pulses. You can see that battery really reacting to it. Start off as 12.2. So yeah, it runs really nice like this. So as you load this one up, it'll go all the way to 5 if you want. But yeah, pretty neat. So we put this prop on here, we'll get a little bit of a load on here. Actually runs better. MOSFETs usually run better with a little bit of a load. So here's the load. So quite a bit faster than the transistor. And now with the load, the input amperage just kind of settles out at a little under 1.5 amps. But our output's really strong. So there's a little bit difference in them. The transistor's really neat because it's just a simple switch, and it's limited by the current of the resistor. So with this resistor on here, this basically limits it at 1 amp for the transistor. The MOSFET could pretty much go probably close to 10 amps if you let it go that far. I would suggest just no more than 3 amps on it, because you want to make sure these heat sinks stay nice and cool. But quite a bit more power. I mean, we could load this down. Gives a lot more torque. So the MOSFETs are kind of neat. A little bit different, but they work really nice. I use them a lot on my motors. Really reliable. So there's a neon bulb on here that's for the transistor. So you could actually remove the output, and gives you a little bit of time. But as far as a MOSFET goes, if you disconnect this output, you're going to destroy that MOSFET almost immediately. So a little bit more temperamental, but very high power. So yeah, pretty cool. So don't forget to check out my store. Thanks for watching.